Hello everyone, I am Chitish Sakya, a software engineer here at Johnston Labs. Currently, I am the lead engineer of our integrations team. Our team focuses on building and integrating our flagship state-of-the-art medical language models on different cloud infrastructure. Today, I am going to be speaking about these topics. Firstly, what are medical language models, or MLM for to be short? Then we'll talk about why to use API endpoints for medical language models. And lastly, how to deploy and use medical language models as API endpoints on Amazon SageMaker, Snowflake, and Databricks. So, what are medical language models? Medical language models are specialized types of natural language processing or NLP models that are trained specifically to understand, generate, and interpret text within the medical and healthcare domain. These models are designed to handle the complex and specialized language used in medical literature, clinical notes, patient records, and other healthcare related texts. Some common medical language models include named entity recognition or NER models. These models identify and classify entities such as diseases, symptoms, medications, and procedures in medical texts. There are also question answering models or QA models designed to answer specific medical questions, often using medical literature as a knowledge base. And there are also text summarization models, which summarize medical documents such as patient records or research articles to provide concise and relevant information. Besides this, there are many more medical language models that are used in various applications. Moving on to the next topic, why API endpoints for medical language models? Conventionally, in order to use a medical language model, you would have to set up an environment, install the required dependencies, download the model, and write custom code to interact with the model. This process can this process can be time consuming and requires a certain level of technical expertise. With API endpoint with API endpoints for medical language models, you can easily integrate the endpoints with other systems and applications, facilitating seamless interoperability. Furthermore, the API endpoints come with comprehensive documentation and benchmarks, making it easier to implement and integrate in your applications. Likewise, the API endpoints are deployed on your cloud infrastructure, giving you full control over the data and ensuring that it remains private and secure. This is especially important when dealing with sensitive medical information. As for speed of development, the API endpoints are pre-built and ready to use, allowing you to make predictions using simple API calls. This can significantly cut down on the time required to develop applications. Furthermore, these APIs are built following best practices, ensuring high quality and reliable performance. Also, you can monitor and manage API endpoints using the cloud platform's built-in tools, ensuring a consistent and reliable experience. In terms of scalability, the API endpoints can be easily scaled up or down to meet the demands of your application, ensuring that you can handle large volumes of requests without any issues. Lastly, as the API endpoints are managed by Johnston Labs, you can be assured that they are regularly updated and maintained, ensuring that you always have access to latest features and improvements. Now to the next topic. Here I'm going to show you how to discover, deploy, and use API endpoints on Amazon SageMaker. You can find models that can be deployed as private API endpoints on SageMaker using the Johnston Labs website. Today, I am going to deploy our medical LLM model to SageMaker as a private API endpoint. This model, medical LLM, excels in answering complex clinical questions as well as summarizing clinical reports into digestible summaries. To start the deployment process, click on the Deploy to SageMaker button available on the model page. This will open up the SageMaker Marketplace listing for the model. There is some helpful information about the model on the listing page. On the usage section, you can find the input format the endpoint expects, as well as the output format the endpoint returns. Next, click on the Continue to Subscribe button and accept the offer. Once you are subscribed to the product, click on the Continue to Configuration button. To launch an endpoint, SageMaker offers either CloudFormation or SageMaker Console or using AWS CLI to deploy your endpoints. We will be using the SageMaker Console to create a real-time inference endpoint. Click on the View Amazon SageMaker button to start creating your endpoint. Next, you will need to follow some steps. The first step is to create a deployable model from the model package that we just subscribed to. To do this, just provide a model name and use an IAM role that has Amazon SageMaker full access policy. Now click on the next button to start the second step. The second step is to create a private API endpoint from our model. Here you will need to provide a name for the endpoint and also create a configuration for the endpoint. You can configure the instance type that you want to use as well as the number of instances. Once you are happy with your endpoint configuration, click on the Create Endpoint Configuration button to save it. Now click on the Submit button. This creates the endpoint and it takes few minutes for the service to start. Once the endpoint is active, you can make requests to it either using AWS CLI or using AWS SDKs. Here, I am going to use a Google Colab notebook and install the Boto3 package, which is the Python AWS SDK. Next, I am creating a SageMaker runtime client using my temporary AWS credentials. To make requests to the endpoint, we need to call the invoke endpoint method on the SageMaker runtime client. This endpoint takes endpoint name as the first parameter, followed by the input that you send and the required content type and MIME types. We will use the endpoint name that we just created. Let's look at the question answering capability of this medical LLM endpoint. As you can see, I have prepared a JSON data where we use our built-in prompt template, the OpenBook QA. I also provide a medical context about the patient, and I'm asking a question: what symptoms did the patient experience after the injury? Now I call the endpoint using the query endpoint function, which internally calls the invoke endpoint. As you can see, the response returned by the endpoint is pretty concise. So its response is based on the provided context. The patient experienced sharp pain in his lower back soon after the injury, which then radiated down to his right buttock, all the way down to the lateral part of his leg crossing his knee. So the endpoint has taken the medical context as a reference point to answer the question, which is what we want. We can also send a custom prompt as part of the input text. As you see in this example, I have instructed the LLM endpoint to answer the following questions so a 5-year-old child can also understand. And the response we are getting is following the prompt.
As you see from the response, it's saying, so you know how sometimes we get really mad or excited or our hearts beat fast? Well, high blood pressure is when your heart beats too fast all the time. It's like having a super fast heartbeat that doesn't stop. And this lady has been having it for 15 whole years. That's the law of time. CDs helps to make sure her heart isn't working too hard. Yeah, so it's answering the question in a simplistic way, like I asked, so that a 5 year old child can understand. Next, let's look at the summarization capabilities of the LLM endpoint. There is a predefined template called summarization that you can send as a parameter to the LLM endpoint to summarize your clinical documents. Next, I want to summarize this medical article on COVID and its effect on older adults on Brazil. So I'm going to send this entire text to the endpoint to see how the medical LLM summarizes this text. So as you can see, it has summarized the text. It's saying that the document discusses the clinical characteristics of older adults infected with COVID-19 in Brazil. It also says that the study analyzed 1,544 confirmed cases of COVID-19, and the overall study suggests that the certain demographic and clinical characteristics are associated with increased risk of death from COVID-19 in older adults, including age, sex, and various health conditions. So yeah, it's able to summarize the text. We can also send an array of text to the LLM endpoint. As you see, I'm sending here an input text that contains an array of COVID-19 articles. And when I send it to the LLM endpoint for summarization, it's able to properly summarize both the text. Similar to the Q&A, you can also send custom prompts for summarization. Here, I am sending the request to the LLM endpoint to summarize this medical text in less than 30 words. And as you can see from the result, the response for the same document is now much more concise and less than 30 words. So this is how real-time inference API endpoints work for this model on AWS SageMaker. The real-time inference is useful when you have a few input data and the responses need to be quick. AWS automatically tracks the usage of your endpoints and bills you accordingly. So when you are done using your endpoint, it might be wise to stop it. To do so, find your endpoints page on AWS SageMaker. From there, you can delete your endpoint.
On the next topic, medical language models as API endpoints on Databricks, here I will guide you on how to discover, deploy, and use API endpoints on Databricks.
You can use the Johnson Labs website to find models that can be deployed as a private API endpoint on Databricks. Today, I'm going to deploy a model that detects oncology-specific entities on Databricks as a private API endpoint. This model extracts oncological entities and relations, was designed to detect and classify a wide spectrum of oncological entities ranging from adenopathy, biomarkers, cancer diagnosis, hormonal therapy, etc. To start the deployment process, click on the Deploy to Database button on the model card page. This opens up the Databricks Marketplace listing page of the model. You need to be logged into a Databricks account to get access to the listing. On the listing page, you will find detailed instruction about the model and also how to use the model endpoint. Next, click on the Get Instant Access button located at the top right corner of the page. A pop-up will show up that displays the model available within the listing. After accepting the terms and conditions, click the Get Instant Access button available on the pop-up. You now have access to the model on your Databricks account. You can start creating endpoints from it. The model is located on a Delta Share catalog. New model versions published will be immediately available to you. In order to start using the model as an API endpoint, go back to the listing page and click on the Preview Notebook button. Every medical language model on Databricks comes with a notebook that you can run to deploy the notebook as a serving API endpoint and also query it. In order to start using the notebook, click on the Import Notebook button. This will import your notebook to your Databricks workspace and you can use a cluster to run it. There are some required input parameters for running the notebook. The Databricks Access Token and Databricks host are required to create the endpoint programmatically from within the notebook. In order to get a Databricks token, firstly go to your settings page on Databricks. From there, click on the Developer menu. You can generate a token from there. Once the Databricks token is generated, copy it and paste it in the Databricks Access Token input on the notebook. The Databricks host URL can be copied from the URL itself. The JSL license is required because this model on Databricks runs on a bring your own license pricing policy. In order to get a JSL license, firstly go to myjohnsonlabs.com. If you don't have an account, please create it with the Create Account button. Next, fill up the sign up form and click on the Create Account button. Follow the rest of the instructions to get your account activated. Once your My Johnson Labs account is activated, you can now buy a pay-as-you-go license from your account. From the Buy a License page, fill up the payment method with your credit card information. Opt in for a trial license if available. Agree to the terms and conditions and click on the Create License button. Following this, a license would be generated for you and it will be available via the My Licenses page. Next, copy the license key from My Licenses page and use it on the Databricks notebook. The hardware target can be used to deploy the endpoint to either a CPU or GPU machine. Next, click on the Run All button to run the notebook. The notebook installs some dependencies, creates an input medical text data, and deploys the model to a private API endpoint via the deploy function. It might take few minutes for the API endpoint to start. Once the endpoint starts successfully, you can start sending requests to it. In order to make requests to the private API endpoints, you can use nlp.query endpoint function. This function takes endpoint name as the first parameter, followed by a string data containing your medical text as the second parameter. As you can see, the endpoint has detected some ontological entities and made some classification on the input document. For example, the left has been identified as a direction with a confidence score. Similarly, the mastectomy has been identified as a cancer surgery, also with a confidence score. And there are other entities as well, each with their own classification and their own associated confidence score. The confidence score indicates how confident the model is regarding the accuracy of its classification. You can also send an array of text to the endpoint. As you see in the example, I am sending two clinical texts to the endpoint. Now we are showing the result on a data frame. So you can see we have ontological entity recognition for both the documents and confidence score associated with each classification. The JSL license used by the endpoint constantly tracks your usages, and you will be billed according to the usage at the end of the month. So it might be wise to stop your endpoint when you are not using it. To stop the endpoint, locate your endpoint from the serving page. Then to the top right, there is a stop button that you can use to stop the endpoint.
On the next topic, medical language models as API endpoints on Snowflake, here I will show you how to discover, deploy, and use API endpoints on Snowflake.
You can use the Johnstone Labs website to find the models that can be deployed as private API endpoints on Snowflake. Today, I will deploy a clinical de-identification model on Snowflake as a private API endpoint and show you how to query it. This model was designed to recognize and anonymize a wide range of PSI entities from medical texts. To start the deployment process, click on the Deploy to Snowflake button available on the model page. This will open up the listing page for the model on Snowflake Marketplace. Make sure you are logged into your Snowflake account. Next, click the Get button. This opens up a pop-up with the deployment option. You can click a warehouse for installation purpose. Also, you can either try the product for free with a trial subscription or buy the product entirely. This will begin installing the application to your Snowflake account. Next, you will need to configure the application. Snowflake provides you a setup wizard where you will need to select the warehouse that you will use to activate the app and also grant the necessary permissions required by the application. The application requires two permissions, one to bind the service to an endpoint, another to start a compute pool that runs the service. Now click on the Activate button. This activates the application and now you can start using it. In the About the App section of the application, there is detailed information on how to use the application and how to query the endpoint once created. Next, click the Launch App button and start running the commands given in the example. Calling the Start App procedure starts a compute pool and runs the endpoint service inside the compute pool. You can use the show compute pools command to see the compute pool started by the application. Once the service starts, you can use the prediction UDF function to start querying your endpoint. By default, the clinical de-identification endpoint takes marks policy to return de-identified text. As you see, I am passing some clinical text with some PSI information, and the response is returning me a de-identified version of that text. This endpoint takes masking policy as a secondary parameter. Using masking policy, the endpoint can return different representation of the de-identified text. You can also send obfuscated as a masking policy to this endpoint so that the response return fake PSI entities. Besides the masked and obfuscated masking policy, this endpoint supports two more masking policies. One is masked fixed length with chars and another one masked with chars. So all in all, four masking policies are supported. Both the masked fixed length with chars and masked chars transform the PSI into asterisk characters. This function, prediction UDF, that interacts with the endpoints can be called on any Snowflake tables via a select query. This can be useful when you have a bunch of medical text stored on a table and you want to run the identification process on it. As you can see in the example, I am creating a table called clinical text and I am inserting some medical text into it. I'm also inserting a masking policy for each record that I want to be performed. Now, with a simple prediction UDF function call to a table, we can perform de-identification on multiple documents. As you can see from the result, each medical text has been de-identified using their own masking policy. The first document using the mask policy returns the output where all the entities are identified and labeled. The second obfuscated masking policy takes the PHI entities. The masked fixed length with chars replaces the PHI entities with asterisk characters of fixed length, and masked with chars replaces the PHI entities with asterisk characters of uneven length. The endpoints are powered by Snowpark Container Services, so you get the full benefits in terms of resource allocation and scaling that Snowflake provides out of the box. Snowflake automatically tracks the usage of the endpoint and charges you for the infrastructure cost as well as the application cost. So once you are done using the endpoints, it might be wise to stop it. This can be done by calling the procedure stop app. This will stop all the services and compute pools started by the application, so you are not charged needlessly.
Next on this slide, I have put some helpful links to get you started with API endpoints for medical language models. Thank you for listening to me. Please feel free to ask any questions you may have. I'll be happy to answer them.